Alright kiddos, welcome back. We're going to continue our nomenclature unit, and today we are going to learn how to name and write formulas for acids. Now, later in the year we spend quite a bit of time studying acids in much more detail. But right now we just need to learn how to write their formulas, and we need to be able to name them so we can include them in chemical equations. Now there are two kinds of acids for naming and formula writing purposes. Binary, made up of two elements only, one of which is hydrogen, and ternary, made up of more than two elements, one of which is hydrogen. So let's start with binary acids. Now not too long ago, on example 13, on page 72 of these notes, we were asked to name the compound HCl. It was correctly named as hydrogen chloride. Now this is true if it's being named as the pure compound hydrogen chloride, but the pure compound exists as a gas at room temperature. So the correct formula for hydrogen chloride is actually HCl with a G in parentheses. Now of course the G indicates that the compound exists in the gaseous form. When hydrogen chloride gas is dissolved in water, the resulting solution is acidic, so the correct notation for such a compound would be HCl with an AQ in parentheses. This AQ means aqueous and is used to indicate that the substance has been dissolved in water. Now, the name of HCl-AQ is hydrochloric acid. Notice the prefix hydro is used. This prefix is used only when naming binary acids. The ending of the ion associated with the hydrogen atom is changed to ic. So let's just do a few examples. I think you'll pick up on this pretty quickly. If I were to name HBr as the pure gaseous compound, it's not dissolved in water, we would name it like we would a covalent compound, a nonmetal bonded to a nonmetal. So we'd name the first element hydrogen. We don't need to use a prefix because there's only one of them. And then we'd change the ending of the second element to "ide." So hydrogen bromide. Okay, no big deal. Once again, no prefix is needed because there's only one bromine. Now, if we were to name this as an acid, first of all, we'd notice the formula has HBr with an AQ after it. It's a binary acid. We know that because it starts with H, it's bonded to a nonmetal, and it's dissolved in water. Now, we would name it as hydrobromic acid. So, we use the prefix hydro because we're naming a binary acid. We change the ending to ic right over here because that's what we change the ending to the nonmetal that's associated with the hydrogen in the acid. And of course we end it with acid. Try the next two examples on your own. So pause the video, try naming HF with a G after it, and then HFAQ, and then do the same with H2S. Alright, welcome back. So HF you probably called hydrogen fluoride, and that is correct. But HFAQ, we recognize it as a binary acid, starts with H, has a nonmetal associated with it, and it's dissolved in water. So we would start with hydro, then we would change the ending of the nonmetal to ic. Now we don't say fluorine ic, we would just say fluoric acid. Is that what you did? Good, let's see how you do with H2S. So H2S, as the pure compound in its gaseous state, would be called dihydrogen sulfide. Right? Nonmetal to a nonmetal, so we're going to follow the covalent or molecular naming system where we would use prefixes if there's more than one of the atom. So there's two hydrogens, so we would say dihydrogen sulfide. Now, we don't use those prefixes when we name the binary acid. We would simply say hydrosulfuric acid. Okay, so we have A binary acid starts with hydrogen and a nonmetal associated with it dissolved in water. So hydrosulfuric acid. So binary acids are pretty straightforward. Well, let me do another one for you, but let's work backwards. Let me give you the name of the acid, and you come up with its formula. So if I asked you to write the formula for hydroiodic acid, what would you do? Well, first of all, you'd recognize it as a binary acid. Why? Well, because it starts with the prefix hydro. Only binary acids start with that prefix. So we know we will have only two elements in it, one of which is hydrogen. Now it acts like a metal with a positive 1 charge. The other one is the nonmetal associated with iodic, which obviously is iodine. Now iodine's in group 17 and it has a negative 1 charge. So the formula for hydroiodic acid would be one of each, Hi. And since it's a binary acid, we would put AQ, showing that it's dissolved in water. Now if I said hydrogen iodide, then I would put HI with a G after it, showing it's the pure compound hydrogen iodide. Okay, let's try another example. I'm not quite sure you're on top of this with me, so let me do another one for you. Let's try this. Hydroselenic acid. Okay, of course you recognize it's a binary acid because it starts with hydro, and hydrogen acts like a metal with a positive 1 charge. Selenic, that must come from selenium. So let's find that on our periodic table. There it is, and it's in group 16, so it would be a 2 negative ion, so Se2 negative. So the formula for hydroselenic acid would be H2Se, and we would put an AQ after it. Now, if I were to name it as the pure compound, I would say dihydrogen selenide. Once again, following my covalent naming system, H2Se gas. Okay? All right. Let's move on to ternary acids. These are also called oxyacids. Well, because oxygen is involved in the acid as well. So ternary acids are recognized by the formula Hy. H is a hydrogen acting like a metal with a +1 charge, and Y is a negative polyatomic ion that contains the element oxygen. So we're going to be using our polyatomic ion chart again. Now, to name ternary acids, it's very important. We never ever start ternary acids with hydro. Please do not start them with hydro. If you start them with hydro, it should be a binary acid. Ternary acids don't start with hydro. To name them, we simply change the ending of the radical or polyatomic ion attached to it, and we say acid. So 8 radicals, or 8 polyatomic ions, become ic acids, and 8 radicals, 8 polyatomic ions, become OUS, or US acids. So let's just dive in and try a couple. H2SO3. Now, heads up, ternary acids do not have to have a Q after them. So we recognize it by starting with H and being bonded to a polyatomic ion. You should recognize that then as an acid. Now, to name this, remember folks, do not start with hydro. You recognize it as ternary. We have more than 2 elements, so we do not start with hydro. So for this, we need to look up the polyatomic ion CO3. So let's find that on our polyatomic ion chart. CO3, look, up there it is, I passed it, and it's called carbonate. Now, let's go back. 8s, so it's the carbonate, right? Remember what 8 radicals become. 8s become ic acids. So I would call this carbonic acid. Okay? Try the next one without my help. H2SO4. What do you guys want to call that? All right, you back? Good. Now, did you look up the polyatomic ion for SO4? Let's look it up together. SO4, here it is. SO4 is called sulfate. So, H become ic acids. Now, you might want to say sulfic acid, but that's really not what we call it. We would call it sulfuric acid. Now, once again, I recognize the name as a ternary acid because it doesn't start with hydro. That's right. So, if we just say sulfuric acid, we know it's ternary. All right, the next one, HC2H3O2. So C2H3O2 is the polyatomic ion. Let's find that polyatomic ion. It's right at the top here. C2H3O2 negative 1 is called acetate. So it's another one that ends with 8, and H become ic acids. So that's called acetic acid. Okay? All right. Let's try a few more, okay? Now, I'm sort of sticking with the 8s to X just to start you off, but they don't always end in 8, the polyatomic ions, and therefore, the acid does not always end in ic acid. But I'm starting you off with all 8s and X just to begin with. All right, now, what if I had the name nitric acid? First of all, I recognize it as ternary because it does not begin with hydro. But I know hydrogen is going to be with it, acting like a metal with a 1 charge. But where does nitric come from? Well, nitric comes from nitrate. Remember on the last page? On the last page, if you recall, X come from 8, so we're just going backwards here. So, nitric must come from nitrate. So let's look up nitrate on our polyatomic ion chart. It's right down here. And its formula is NO3 with a negative 1 charge. So it's NO3 with a negative 1 charge. So what's the formula for that acid going to be? Well, the H is positive 1, the nitrate is negative 1, so we just have HNO3. One of each will balance the charge. Now, what if I asked for nitrous acid? Hey, we've got one that ends in OUS. So let's go back a page. And remember that if it's an us acid, it ends, or the radical comes from an ite radical. So this must come from nitrite. So let's look up nitrite on our polyatomic chart. And nitrite is right here, right below nitrate, NO2, negative 1. So we're going to have a hydrogen acting like a metal with a 1 plus charge, and nitrite is NO2, negative 1. One of each will do, so the acid is HNO2. So that's nitrous acid. Okay, let's try a few more. How about H3PO4? H3PO4. So we know it's a ternary acid, has more than 2 elements in it. Let's look up PO4 on our polyatomic chart. So PO4 is right here. Here it is, it's 3 negative and it's called phosphate. What do 8s become? That's right. So we'd call this phosphoric, not phosphic, but phosphoric acid. Okay, you try HMNO4 on your own. Pause the video and come back when you're done to check your answer. All right, we're back. MnO4 is the polyatomic I want to look up. So let's find MnO4. Here it is. It's MnO4 negative 1, and it's called the permanganate ion. So H become X, so this is called permanganic acid. Okay? All right. Let's try writing the formula for chloric acid. So we know it's not binary. There's no hydro in front of it, so it's a ternary acid. So where does chloric come from? Well, X come from 8s. So we need to look up the chlorate radical on our polyatomic chart. So let's find chlorate. See, there's perchlorate. Let's find chlorate here. Here it is. Here's chlorate. It's ClO3 -1. So it's ClO3 -1. Hydrogen will act like a metal with a 1+ charge. And since that's +1 and the chlorate's -1, we just need one of each. HClO3 is chloric acid. Okay? Alright, I think that's good for this video. When you come back, we have lots more examples to do. So come back for part 2 of naming and formula writing for acids, and then we're going to review ionic compounds on that video, and we're going to do molecular or covalent compounds again as well. So we'll see you soon. Bye-bye.